All right, so you should make sure that you've updated your vocabulary tree. Of course, this doesn't have all the words we added. As I add the words, it won't have all of your words there. I'll just add them as we go, and of course, yours will become bigger, and it become bigger, and it become bigger, and sometimes we may have to add another tree, but I'll just add the tree and add the words as we go. Mine won't multiply here. Mine will multiply on the wall. Any questions with that? Okay, someone had a question for me. They caught my name. Yes. Good. All right. I want to go over a couple things on the lab that we did last week because some people were making some careless mistakes, and some people, Patrick, I already talked to you about that. And some people were making some mistakes that maybe it showed me that you didn't quite get something, and I need to re-review that. So let's take a look at our lab. We're going to look at, I was noticing a trend of mistakes. So we're going to look at station 4. So let's go down to station 4. All right. If you recall, this was the lab where we had 2 different liquids and 2 different solids. We had a liquid oil and we had a solid oil. How did we make the oil solid again? Raise your hand. Jenny? Froze the solid oil. And it became frozen oil. And then we had liquid water and solid water, okay? In this experiment, we took the solid oil and we put it inside the liquid oil, which brings us to question number 3. What does solid oil do in liquid oil? What did the solid oil do, Patrick, in liquid oil? It sank. Some of you got that. That was fine. That wasn't where the problem came in. Then it asks, which is denser, solid oil or liquid oil? Now, I want you to notice one thing. Under 3, you have a 3A. So, obviously, that A goes to question 3. So, I'm talking about the materials that we used in question 3. This was testing your vocabulary of the word dense, because we talked about that where? In your notes. So, which was denser, solid oil or liquid oil, Ray? Solid oil. How do you know it was denser? Because it what? Because it sank. So far, so good, right? Yeah. Jenny, question. Okay. Then we moved on and we took the solid water and we put it inside the liquid water. What did it do?
Oh, it flowed.
Okay. But first it asks the question, what is solid water? This is where I began to pull my eyebrow hairs out because I was getting answered like, solid oil, aka solid water. I was getting answers like, I don't even know. Solid water is ice. I don't understand why people were having such a hard time with understanding that solid water was ice. Okay. Then number 5 says, what does the solid water do in the liquid water? What did it do in the liquid water? Somebody else. Dewey. It floated. Okay? So I got answers like oil something there, and I'm like, the question says, what does solid water do in liquid water? And they were not answering the question. They were answering something else, and I have no idea why. Then, if you look at A, 5A goes to, pay attention here, 5A goes to what? Number 5. So when a question asks, which is denser, I'm asking between what?
Water and
solid water and liquid water. Those are the only things that I was looking for. I was getting solid oil, aka oil. I'm like, I don't understand. I had to say between these two substances. What? I need you to pay attention here. There's nothing out there that's going to help you. All right, which was denser, the solid oil? I'm sorry, the solid liquid or the
That's it. You don't provide something.
okay, it's fine. It's just the air. Which is denser, the liquid water or the solid water, Drika?
Liquid water.
Liquid water. And this was again testing your knowledge of the word dense. Drika, how did you know that the liquid water was denser?
Because the ice didn't.
The ice didn't sink. The ice floated. So because the ice floated on top of the water, therefore the water must have been denser than the ice. Then, down to number 6, talking about in order for the ice to float, what had to happen to the molecules. The question asked about the molecules. Some of you were giving me answers about something else. We looked at this in your web quest on the back of your properties of water worksheet. That very top question, it asked about what was so different or peculiar about solid water. And what did you learn in your web quest about solid water? We learned that it floated because it expands. And you had to say something about the molecules expand. And when they expand, they create air bubbles which allow them to float in the liquid water as opposed to other substances. Dewey? Oh, this tells me you have a question. You don't have to say it after you raise your hand.
Okay, I'll
Yes.
I remember you talking about when we have water molecules in the air. How come sometimes when you don't drink water? I'm not trying to be funny or whatever, but how come when you don't drink water, your mouth feels dry and you feel like you feel very thirsty?
Because you're dehydrated. If you don't drink water, you're dehydrated.
But doesn't the water can't the water molecules up?
Is that enough?
Might not be.
That's not enough. No, you need more. That's not enough. That's why it doesn't help. All right. Moving on. I want us to now go to section 6, station 6, section B. Here's where I noticed a lot of points were missing. Number 1 is because you weren't doing the work. Number 2 was because you weren't following directions. And number 3, because you weren't looking at your notes. So, I want to take a look here. Just give me 1 second, Drika. At this section right here. Drika, question.
For section B, you didn't mark anything.
If I didn't mark anything, then you didn't get it wrong.
Because on the other ones you were putting checks.
Yeah, as I was going through, I was like, okay, I don't need to check at this. All right. The volume of the water in the graduated cylinder. First of all, the question is, how did we get the volume of the water in the graduated cylinder, Bryson?
We filled it up to 10 milliliters.
We filled it up. We poured it in there. Did we have to do any math? No, we poured it in there and we read the graduated cylinder, or in the video's case, the beaker. I want to get the beaker amount. What was the amount that we saw from that video when we did the virtual lab?
10 milliliters.
No, from the video.
Oh, I didn't want that.
100 milliliters. So we're going to use that. It's important that you put the unit of measurement, because I said to you in the very beginning, if you do not have the unit, then it is wrong. Because the volume is not 100, it's 100 milliliters. All right. Then the mass of the graduated cylinder with the water. How did we get the mass, Ray?
We added
No, we did not do any math. We put it on the scale. There was no math involved here yet. We put it on the scale, excuse me. Then we read the scale. What did we get, Jenny?
20 grams.
With the graduated cylinder and the water? Madison? 120. This was the two together. 120 grams.
My group, we put 10.
I know, because you guys were actually at the station working. We did, I'm just taking the
that's the
virtual.
video.
Yeah. All right. Then the mass of the empty graduated cylinder. How did we get the mass of the empty graduated cylinder? and poured the water out. Bryson, thank you for raising your hand. After Bryson said we poured the water out, then what did we do?
Put it on the scale.
Put it on the scale. And the scale told us it was what?
20 grams. 100.
20 grams.
20 grams.
20 grams.
All right. Now we needed to find the mass of the water. How in the world could we have found the mass of the water, Jenny?
You subtract the mass of the graduated cylinder with water and with the mass of the empty graduated.
So we started off by having the graduated cylinder with the water. That equaled 120 grams. Then we had a graduated cylinder that was empty, which equaled 20 grams. So just to get the water, we had to do what to the two? Subtract to give us 100 grams. So this was our first portion where we had to do math. But it was very simple math, correct?
Yeah.
Okay. Then we now move on to the part where I started pulling out my actual hair out the top of my head. Because a lot of you got it wrong. Because number one, you didn't do it. Number two, you just showed me the formula, but you didn't plug any numbers in. And number three, you answered F without answering E. And F says, how does your calculation of density compare? How in the world can you give me an answer here when you have not done anything here? You don't have a calculation to give me the answer. Therefore, how did you answer F? So I was getting very frustrated at that point. So now, going back to E. What was the handy-dandy little thing that I gave you to help you figure out density? Is Drika, Aaron, and Bryson the only one, and Jenny, and Ray, and Patrick? Oh, there we go, Eddie.
Oh. You gave it the triangle?
The triangle. I'm going to put it over here just so we have it. And how is this triangle set up? Drew.
M over D.
Give it to me from left to right. What goes here?
The D.
Uh-oh. Guys, grow up. I'm going to make the triangle bigger so I can write in it. What goes here?
The D.
Okay. The letter D.
And then the B on the
Give it from left to right. What goes here at the top?
Oh, the top, the M.
M.
And then the right
And then the V.
side.
I try to make you remember it like that so you remember D and B so you remember where they go, because if you put them in the wrong box, your calculation will be wrong. Now showing your work. All of you had Mr. Torrance last year, so you know the importance of showing your work. Showing your work starts off with the what?
The formula.
Formula. What's the formula for looking for density? Thank you, Drika. You threw your voice way over there. You are a genius. What is it?
Density equals mass over volume.
Good. D equals M over V. All right. Now, some of you got that portion. Then you started plugging in numbers that made no sense. What is E asking for?
The density of water.
Just don't worry about it. The density of water. So therefore, we need to plug in the mass of what? Water.
Grams over milliliters.
No. I didn't ask for the unit yet. Pay attention. Shh. To put the mass there, we need just the mass of water. What is the mass of the water?
100 grams.
100 grams. Patrick.
He said that first.
And you had to repeat after him. To find the density of water, we have the mass of water. We need the volume of. We need the volume of water. Just the volume of water, which is
100 milliliters.
100 milliliters. Then some of you told me that 100 divided by 100 was 0. Hey, I'm just telling you what I saw in the work. Which means that you are rushing because you all know that answer. It's not that you're stupid or you're dumb. You know the answer. You were just rushing to get it done and not really paying attention to what you were doing. So 100 divided by 100 is
1 gram.
1. The unit,
1 gram over milliliters.
you have gram over milliliters because we cannot cancel out those units. We have to put those there. Now, the question F asks, how does your calculation of water compare? Here's where a lot of you got stuck because you didn't understand what compare means. Compare means what are the similarities? Where did you look for, Duran and Brian? Where did you look for the similarities between your answer and what density should be? Ray.
The density of water is...
No. Where did you look? Answer my question. In your notes. According to your notes, what is the density of water? Akai. What's the density of water according to your notes? The rest of you put your hands down. 1 gram over milliliter. How does the density of water, which she said is 1 gram over milliliter, compare to your answer?
It was equal.
It's the same.
Tells you.
So this was to show you that the density of water will always be
1.
1 what? 1 gram over milliliter. Remember, the properties of water are to identify what that substance is. Remember our crime scene. If we have a liquid and we need to know what it is and we test it and it is 1 gram per milliliter, we can say that that liquid is water. Any questions on this part? Hope that you made corrections. Jayla, put that book back down. Same, with the exclamation point. All right. The last part I want to look at is Station 7, Part B. Well, actually, just Station 7 for that matter. Brian, not right now. All right, for Station 7. This top part. No one should have gotten this part wrong or this part wrong. Why? We did it together. So if you got it wrong, it's because you were lazy and you did not do any writing when I gave you the answers right there.
And we did the box together too.
We did the box together. However, when we say together, I told you to do it, but I didn't tell you what to put there. You had to come up with your own observations. So, some of you got points taken off on the box because you just left it blank. Moving down to the question where it says, explain what is happening to the celery in terms of the properties of water. This was very important because it said in terms of the properties of water. You had to use a specific property. You could not just tell me that the water was seeping up the celery. What property is that? Go on.
Capillary reaction.
And you may have saw me write it on your paper in capital letters because at that point I was getting frustrated because we didn't pay attention to this. Any questions on your lab? No? Okay, very good. Then let's take out our groundwater vocabulary and note sheet. Now remember at the bottom of your note sheet, my turn. I need you to focus, Jill. I'm going to move you up here. Remember at the bottom of your note sheet you had the picture that looked like this?
Yes.
You have a quiz coming up on Friday. Your quiz on Friday is going to quiz you on the water cycle and groundwater stuff. So anything we do on the water cycle, anything on groundwater will be on your quiz on Friday. So therefore, you need to study this. How did I say you were going to study this? Well, you do have the song to study the water cycle. How are you going to study what's going on in this picture?
Oh, you can.
Trika.
Oh, you well, the part where we filled in the answers and then you guess.
Very good. Fold down the bottom part because yours looks like this. Fold down the bottom part where the answers are, and then start pointing to and labeling it. So sometimes some of you may have your mom or your sister, your brother, your cousin, or somebody quiz you like, hey, can you quiz me on these? They don't have to figure out the answers. They're right there in front of them, and they can quiz you just like that, or you can do it yourself. You don't need anyone to help you. Any questions on that? Okay. Then remember on Friday, we watched a video about groundwater. Okay, I'm going to show the video one more time just so you can get some information that you may not have gotten on your note sheet that looks like this. Remember what I said. The video is not going to stop for you to write. Write what you've heard. If it continues to go and you miss something, just pick up where you stop writing. Chances are you won't get everything. All right? You will have to skip something and move on because it won't go in order. If you hear something that sounds important, jot it off to the side. These are your notes. You can do that. Bryson, question.
Where's supposed to be groundwater?
Yes, the entire thing. The paper says Groundwater Notes. And then it breaks down the groundwater movement, but the entire thing is your notes. The entire part is just broken down into sections. Yes, the video will go with both. There will be a little bit of a part where you won't come from the video, it will come from your knowledge, but the video will cover 95% of this. All right? So I'll play it once more.
We all know the Earth is full of water, but there's a lot more to water than all that blue stuff you see on the globe. The water we can see on the surface of the Earth is surface water. Surface water is every lake, pond, river, stream, and ocean on Earth. But in the ground below your feet, there's even more water, groundwater. Groundwater is water that's crammed in the tiny gaps between rocks, soils, and sediments under the ground. A full body of groundwater is called an aquifer. There are huge aquifers all across America. The biggest is the High Plains Aquifer, which covers 174,000 square miles right in the middle of the country. Anything that big deserves a closer look. Let's say you could grab a shovel and dig straight down through the soils to an aquifer. The level underground where you first hit groundwater is called the water table. Below the water table, the ground is completely soaked or saturated with water, which is why this area is called the saturated zone. The area above the water table is called the unsaturated zone.
Also known as the zone of aeration.
So, how does all this water end up in the ground? Well, it's all a part of the good old water cycle. When it rains, some water gets soaked up by plants. Some water runs off the soil and into streams, lakes, or even the ocean. Other water gets sucked from the surface and eventually evaporates back into the air. Meanwhile, some of the lucky water droplets get to travel down through the surface deep underground until they reach the water table and become a part of an aquifer. Once water seeps down deep enough into the ground, it can stay there for a really long time. Some of the water stored in the deepest parts of aquifers has been there for thousands of years. But after it gets there, groundwater doesn't always stay in the ground. A lot of the water on the surface comes from aquifers. If the surface of the ground dips below the water table, groundwater flows out into the space, creating a body of surface water. If the surface water dries up, groundwater can flow in to fill it back up. And if the water table in this area rises, so does the level of the surface water. Groundwater can also pour down a sloping surface, creating streams. Any place where groundwater flows out into the surface is called a spring. Surface water can also become groundwater. If a body of surface water flows above the water table, water can seep down through the sediment and help fill the aquifer. Of course, there's another way that groundwater can leave the ground. Us. Humans depend on groundwater, and there are thousands of wells all over the country that draw water out of aquifers. In many parts of the country, the water you get from the tap comes from the ground. However, we use most of our groundwater to help grow the food we eat. Farms can get lots of the water they need from rain, but rain isn't always enough. And in dry years, farmers depend even more on the water that's stored in the ground. In fact, American farms use about 53 billion gallons of groundwater every day. That's enough to fill over 1 million bathtubs or 80,000 Olympic-sized swimming pools. So, if we're using that much every day, can it run out? Well, yes and no. Remember, aquifers can be refilled by rainwater or surface water seeping in from rivers and streams, so there's usually more water on its way to replenish the aquifer. But if we use groundwater faster than the aquifers can refill, we could drain them dry. They probably wouldn't be empty forever, but it would take hundreds of years for the largest aquifers to get back to healthy levels. Whether it's up here or down there, water and how we use it matters. We may not be able to see it every day, but groundwater makes our lives possible. So don't let show-offs like rushing rivers and roaring oceans get all the attention. Those unseen aquifers below ground have been here longer than we have, and with a little love and care, they'll keep on taking care of us long into the future.
All right. So now let's look at our notes and let's see what it is that you got. This is the same thing you have. This is the top portion of your notes. And then the next slide will be the bottom portion. But background knowledge. What is surface water? What is surface water? You gotta put your hand up and then you put it down. Why? Bryson.
Water that's on the surface.
Water that's on the surface. Water that you see, which is, they gave us some examples. Lakes,
Rivers,
streams, gulfs, oceans, all of those. Okay, all of those are our surface water. It's the water that you see. Then we'll move down to groundwater. And it says water enters or breaks the surface and enters the underground through a process called what, Patrick? Infiltration. My writing on here is going to be a little sloppy because my pen is kind of thin, in a thinner stylus. There, the area below ground but above the zone of saturation, this was testing your vocabulary, is known as the zone of Madison. Zone of aeration, also known as the unsaturated zone. Underneath, if you wrote aeration, I want you to write unsaturated as well. If you wrote unsaturated, I want you to write aeration so that you know the two mean the same when you're studying. I also want you to underline or highlight, this is where percolation occurs. That's where what is percolation again? Movement of water. That's where the water's moving. Good. Come out. Groundwater is found underground in between, okay, rocks, soil, and sediment. Who knows what sediment is? Jenny.
It's like rock, but it's like smaller and it's like more with soil.
Yep, it's different pieces of rock crunched up and mixed with soil. Good. The area underground that contains a full body of water, it's where our groundwater is located. Ray, this is your aquifer. Good. And then we have this area that is above groundwater and splits or separates the zone of aeration and the zone of saturation. What is that? Come on.
Water table.
This is your water table. The area where groundwater is located is known as the zone of, Chris? Saturation. Good job, guys. And then If the water table is higher than the Earth's surface, this is going to form, Rogerlyn. Huh? No, not necessarily. A stream, but I'll say a stream is no, not a stream. Surface water, which is an example is a lake. This is how we get our lakes. When your water table becomes higher and it starts to seep out, we get lakes like that. Questions about the top portion? Okay, well then let's go ahead and look. One second. Plug up the charger. Let's look at our bottom portion where it says groundwater movement. Now this was not in the video. This was testing your knowledge of the vocabulary that we did. Groundwater flows through a specific type of rock. So it's rock that allows groundwater to flow. Akaya. You put your hand down? Change your mind? Devin? Permeable. Very good. I told you it's hard because I got something else on the top of my screen that pulls down. So permeable. Permeable means what? Rogerlyn. It means it's able to let water pass. Very good. The water flow stops where the rocks are impermeable. Impermeable rock would also be considered a blank, which is an earth layer that does not permit water to flow. Jamil? Yeah. Patrick? Nope. Groundwater is where water is able to flow. Drew? Aquitard. Very good. Yes? Well, I'm sorry? An aquitard is not specifically an earth layer, but if you have some parts underground where water can't flow, we would call that an aquitard. Question, Brian. All right. Us humans, that's us, and we are also considered animals, right?
Yeah.
Okay. We depend on Dewey, groundwater. Which is the same thing. You could put in parentheses aquifers, but aquifers is in our groundwater, or groundwaters are aquifers. And this is, what do we use to draw water out of the aquifers, Chris? Wells. Now sometimes the rocks push up, because remember our earth is always moving, and sometimes that pressure, it pushes up. And when it pushes up, it may push up a part of the aquifer, and it may push up to the land, which breaks it, and then water comes shooting out of it. And when it shoots out of the surface, Madison, that's a spring. How many of you have ever held a spring in your hand and did it like this, and it kind of pops out? That's why we call it a spring, because it springs out, and that's where you get your spring water from. They call it spring water because they got it out like that, where the rock may have broken and let the water shoot out. Kind of. But a geyser is where heated water shoots out. But you do have geyser springs. All right, how do we use groundwater, Jayla? So our farms. Yep. Farms and help grow food. Remember, although you go to the grocery store, that food comes from farms. What happens if humans use groundwater faster than the earth could replenish? Devin. Which means the wells would do what? Yep, the wells dry up. You keep your hand raised, you don't talk. Which would be like a drought. Question. Okay, what do you need?
It'll take 100 years over hundreds of years to regenerate.
It didn't ask how long it would take to regenerate, it just asked what happens. It dries up. Any questions for your notes? No? Okay, so we're good with that. All right, I want you to take out a separate sheet of paper, and this is your page 8, and put the title here. Can you taste the difference? And what page number is this? Page 8, so please make sure you put the page number on it. I never let the cat out the bag until we actually do it. Yes, Devin? No, this is just notes. So you don't need the proper heading on this. Dewey, I need you to sit down. Sit down. Stop getting up. Thank you. Put the heading just like I did here because these are just notes. It doesn't need your name and all that stuff on it. Drew? You need to turn around? Yeah. You can actually turn that seat this way. So it's facing here. That's good. Devin, if you want to turn your chair as well, you can. My next class, he needs the chair turned like that anyway. Okay. Everyone have the title?
No.
Put that chair down. Put that chair down. Alrighty. After the title, you're going to write what distilled water is. There's a certain thing that you can buy called distilled water. Put your hand down and write. It virtually, meaning that it removes just about or tries to remove all of the impurities through a process called distillation. And is it all written? Right, so that you can ask your questions so you're not slowing yourself down. Is it all written, Brian? Move up. Do you wear glasses? Where are they? Where are they? Where are they? Okay. So even though we pump water out of the wells, some people have wells in their backyard that they pump it out of. We all get it out of the faucet. And then some people buy it from the store. And it may come distilled, where that means it went through a company and they tried to remove all of the impurities. Distillation is boiling the water, then condensing the steam into a clean container, leaving most of the contaminants behind. I'll wait while you guys do that. So the process of distilling water means they boil it. When they boil it, the steam, the fresh water goes up. All the bad stuff, or just about all the bad stuff, stays down. And they capture that steam and they bottle it and they put it in a container for us to drink. And we buy it hoping that all of the impurities, or just about all of the impurities or bacteria, are removed. Well, you can't get rid of all of it. Like, they get rid of as much as they can. That's why we say virtually. Are you still alive? Have you been drinking it? Are you still alive? There just may be some small microorganisms that we just can't get. Bacteria. Yeah, close it and that's it. Stop clicking and clicking. Look up when you're done writing this. Okay? Questions? I'm going to move to the next one. I'm not taking this off the screen, but I am going to move and just have it there. Another type of water is your spring water. And your spring water, we've learned, it comes from the earth, from below the surface where the aquifer meets ground surface, and then it springs out. You need to be writing that. Notice that this is a natural water that comes out of the spring, but it has not went through a process of cleaning. It would be thought to be the freshest water until they realize that the ground has contaminants. The ground is not a natural cleaner. Some people think that spring water is fresher than the water that is filtrated from our water systems because we add stuff to clean it, and they wouldn't want those things in their water. Some people think that the water that comes through our systems is cleaner because we add stuff to clean it, and spring water does not add anything to clean it. So it just goes through the natural process. Yes. It's in a container. Liquid takes the shape of whatever the container is.
Yeah, but like, somehow real stiff.
It's the way the plastic is made, honey. And then the last type of water that we'll be talking about is tap water. Tap water is the water that comes out of the water fountain, the water when you turn on your sink, the water when you turn on your shower, the water when you turn on your water hose. That's tap water. That comes right from the faucet. It's minimum purification, which means that it goes through your water treatment plant where they add chlorines to clean it, run it through, and then run it through the pipes, through the wells, then through the pipes so that you can get it through the pipes into the wells so you can get it into your homes, into your schools, into your churches. Yes, it does go through the pipes after it's been through a filtration system. Chris. That means it.
But if it goes through the faucet and stuff like that, and it goes down the drain, does the water go back?
The water that goes down the drain has to go into your sewer, which goes back through your water treatment plant, which gets filtered and cleaned to get back to the pipes to get to you.
So why do they say that we might
Because if we damage our water and we're doing stuff to our water that can't be cleaned, that's how you run out of water. Not run out of it meaning we won't have water, meaning we won't have usable water. Good question. Oh, that they're probably talking about water that has carbonation to it. They have certain water that has been carbonated. They just add carbon dioxide to it and it gives like a fizz, like you have your soda with the fizz. Sparkling water. People like that type of flavored sparkling water because some people think water is very bland and it's tasteless. So they have that carbonated or whatever. It's a matter of choice. I don't like it. A matter of taste better is a matter of preference. I don't like it, but somebody else may like it because they don't like drinking water, so they just drink it that way. Just sparkling water, bubbly water. Jenny?
I'm not saying that, but if you drink water out of the water, that's safe.
That's actually a good question. The water in your toilet is actually the same water that comes out of your faucet. It is. The only way it becomes damaged, that's why some people let you get your dogs lick out of it. Only way it becomes damaged is number one, if your toilet's not clean. Number two, the people think it's gross because we do use the bathroom in there, so I wouldn't do it. But if you had a brand new toilet that just came in and it filters through, that's the same water that comes out of your sink, which comes out of your shower. How come who? People don't give their children tap water for a couple of reasons, but we'll talk about a little bit later, but I'll tell you now. It's because of the purification that it goes through. It's chlorines added to that water to clean it, so it still has a little bit of chlorine in it. So people, to you, that's a matter of choice. All right, any questions on this? Everyone have this all written? Raise your hand if you do not. Okay, I'll give you a moment.
Oh, can you purify some water for like some tropical flora?
You can. Some people take tap water and kind of try to distill it on their own by boiling it. No. Can I move from here?
No.
1 second, just gotta get something else down. I'll wait. Madison. Oh, that's a good invention because a lot of that is happening. She said there's a new invention for like I guess like when people are going out to parties or clubs that it's a cup where it filters out anything that's been added to the cup that shouldn't be there. Like a lot of people are putting like drugs in other people's drinks, date rape drugs and things of that nature. So that's a really good invention. While you're copying this down, another thing, I'll say that for later. Yeah. All right. Underneath those definitions, I want you to write in the middle of the paper, taking up one line, write the word observations. On the middle, right underneath the definitions. Did you write that down, Duran?
Yeah.
Okay. Then you're going to copy a chart. You only need, you don't need a big chart. So notice how it's just one line for each thing. Go ahead and copy that chart. So you have 1, 2, 3, 4 lines going down. 1, 2, 3, 4, 5 columns. So 4 rows, 5 columns. Rows go this way. Columns go this way. It doesn't have to be perfect. For those of you who try to make perfect lines and get rulers out and all of that, we don't really need that. Once your columns are done, you may have to go to the back. You might not. You might have some space where you can stay at the bottom. And then you'll have to go to the back. What we're doing is setting up for a demonstration that we're going to be doing tomorrow. Yes. Make sure you put water sample, appearance, smell, taste. And I think this is. Okay? Then you're going to write, number 1, I think distilled water is cup blank because, and then just leave a blank line underneath because so you have space to write your answer. So this sentence, this portion of a sentence should only take up one line and then leave a blank space. Take out another pencil because you're not going to keep getting up. Take out another pencil. I'm going to show the rest of them. You're going to do the same thing, write them down and skip a space after. Duran, what do you tell him? Okay. Eddie, mind your business. Duran, just keep writing. You don't have to justify it to anyone else. And then if you need to go to the back, you can go to the back.
1, 2, and 3 is for.
Yeah, you can go to the back. What water? What are you talking about?
If it's not cold, I'll put
I'm sorry, I don't know what you're talking about.
it. Taste. So I gotta go taste it.
Maybe I'm tasting it. All right. And then you're going to write down number 4. Drew? Did you write this down? When you're finished, look up because we just have one last thing to write and we're done. It's just the air. Are we good? Okay, I'll give it a moment. Everyone's good? No. Who said no? Talk for yourself. Does anyone else still need time? Okay, go ahead. Quickly. Don't give me that face when I say something. You gotta wait a minute. Wait. We're not about to start this. We're going to the bathroom. Hold on. Yes. Can I go to the next one? Jayla, you good? All right. You don't have to write this portion. Answer this in a complete sentence. You don't have to write that. Just write this question. And then you're done.